Thank you for joining this conference and in particular this speech. Today we are going to talk about the different kind of deltas we have in the Yanchang Formation, the Triassic Yanchang Formation in the Ordos Basin. The result we are going to show during this presentation is part of a collaborative project we perform with PetroChina and our university in Argentina. So we are going to move across different topics. We are going to start with the objectives of this speech. We are going to show the study area and the geological setting of the Ordos Basin and in the particular the Yanchang Formation. We are going to discuss a little bit previous interpretation about deltas in the Ordos Basin and particular in the Yanchang Formation. We are going to discuss some new paradigms about the understanding of delta deposition. We are going to discuss the evolution of the Ordos Basin and the consequences in delta deposition. We are going to finally go into some conclusion of this study. So, the objectives of the talk today will be to discuss the classic paradigms of delta deposition applied to the Ordos Basin, applied to the Yanchang Formation. We are going to analyze the evolution of the Ordos Lake according to the result of this new study, in which we have a new sedimentological and stratigraphic model. We are going to discuss new frontiers in the analysis of delta sedimentation and provide a practical application to the understanding of the Yanchang Formation and how this Yanchang Lake constrain the different kind of delta we have in different situations or during the different evolution of this basin during the time. So, for starting, we are going to show the study area and the geological setting. As you know, the Ordos Basin is a large, very large continental basin developed in the center of China. It's a very big, it's a huge basin. It's part of a very extended foreland basin, a totally continental foreland basin for the Triassic. And in this basin, you have the accumulation of a very thick stratigraphic column, more than 1,000 meters thick. Conventionally or classically, in this stratigraphic column was divided into 10 different members. All Chinese geologists know these members. These are some kind of lithological or operational members from Chan 10 at the bottom up to Chan 1 at the top of the base of the Yanchang Formation. All this all these deposits was accumulated during the middle to late Triassic. And the Yanchang Formation forms a complete transgressive regressive cycles. In the middle, you have this main source rock that make the Yanchang Formation very important for the economy of China, for the hydrocarbon production in China. As we discussed earlier, this is part of a joint collaboration between PetroChina and our university in Argentina. During this project, we had the opportunity to make a complete revision of the stratigraphy and the sedimentology of the Yanchang Formation. We have measured 29 sedimentary sections, and we made a lot of different stratigraphic panels at different positions. This allowed to completely review the sedimentology and the stratigraphy of the Yanchang Formation. This is the location of the different sedimentary sections in the Sichuan, Yan'an, and Yanchang and Shannan areas. We make a joint effort trying to do our best in get a lot of detailed description from the field. So, as a result, we had the opportunity to build a new composed stratigraphic columns in which in this column we can recognize different sequence stratigraphic units. For example, at the very broad scale, the whole Yanchang Formation composed a complete transgressive regressive sequence, a second order sequence. In turn, this sequence can be subdivided into 3 mega sequences: the lower mega sequence, the middle mega sequence, and the upper mega sequence. This mega sequence can be in turn subdivided into small scale or high frequency cycles or higher frequency sequences. And at the same time, we analyze the relationship between these sequences, the positional sequences, and variation in lake levels, as we are going to discuss during this speech. So, these mega sequences, the understanding of these mega sequences is very important because they are going to control the kind of delta we can develop at the different positions. So, as you know, from the beginning, deltas were recognized in Ordos Basin. In most paleographic diagrams you can see from the Yanchang Formation, you can recognize these paleographic maps showing inner lake or deep lake areas here in blue, surrounded by these delta front deposits and channels with delta plain and coeval fluvial deposits. And in the middle, for example, we know that there are some very thick massive sandstone intervals. So the positional model was at the beginning very simple. The positional model take into consideration littoral deltas. This model of littoral deltas was taken from the models of marine littoral deltas. So these deltas with Mohs bars and delta front, delta plain, and some channels in the delta plain, and at the same time the sandstone in the inner part of the basin were explained as sandy debris flows or cohesive flows with part of the delta front that collapse and accumulate in the inner part of the basin. The model of the sandy debris flow has some problem because we know that the topography of this basin was very gentle, so it's very difficult to justify these cohesive flows. And additionally, the deposits this sandstone deposits has very low clay content, so it's very difficult to support the cohesion we need for a sandy debris flow. But in more recent years, a different interpretation appears for the interpretation of this, for the origin of these massive sandstone and inner basin areas related to hyperpigmental flows. These hyperpigmental flows are produced by this fluvial discharge when the river supplies a mixture of water and sediment with a density which is higher than the density of the water and the rest of the reservoir. So these flows can bypass coastal areas and accumulate the sandstone at the inner basin, also with very low gradient in the lake. This is possibly a different depositional environment, more consistent with the evidence you have in this Yanchang Formation. But again, the model was very simple with littoral deltas and these subaqueous deltas. In recent years, our understanding about deltaic deposition changed a lot because we have new paradigm, we have new understanding about how delta deposits forms and accumulate. For example, now we understand delta deposits as the deposits directly supplied by a river in a basin, not just the littoral delta part or the littoral area of a delta. As if we go into the classic of the milestone interpretation of Bates in 1953 provides a different classification for delta, considering the different relationship we have in between the density of the incoming flow and the density of the water in the receiving basin. So you have three different situations. In the first situation, the density of the river discharge has a density which is lower than the density of the water in the basin. Typical situation when you enter fresh water into a marine environment. So you are going to develop this, all sediment will be forced to accumulate in coastal areas, forming this kind of littoral delta. In the second kind of delta, you have a river discharging a flow with a density similar to the density of the water in the basin. So in this typical situation of a river entering a freshwater lake, so sediment collapse at coastal area and we have some kind of typical littoral deposit. The most common is the Gilbert kind of deltas or Gilbert deltas, periquartz grained delta. Finally, we have this situation in which the density of the fluvial discharge is higher than the density of the water in the reservoir. So as a consequence, the flow plunges and moves basinward as like a turbidite, like a sediment gravity flow originated in the continent that travel and transfer a lot of sediment basinward. Of course, this model for understanding delta deposition is very smart, but is just a simplification because we have a lot of different kind of gravity flow entering the basin, and we also have different kind of concentration of the water in the receiving basin. So, and we are, as you know, in nature you have a lot of different kind of flows of having different densities. For example, from cohesive debris flow, hyperconcentrated flow, concentrated flow, and sediment-laden turbulent flow. All these flows has different concentration, different rheology, and is going to react in different way with the receiving basin. So we are not going to generate the typical littoral deltas or the typical subaqueous delta. We can have a lot more, different more possibilities of different kind of delta. In recent year, we have worked in a different model for understand delta situation, delta sedimentation. In this model, is going to appear in next month in the Journal of Paleogeography, and we are going to discuss this new interpretation, in which you have this diagram showing different kind of deltas related to the interaction in between sediment concentration from clear water rivers or stream flows, then go into dirty rivers, concentrated flow, hyperconcentrated flow, and so on. And on the other side, you have the salinity of the receiving basin that influence the density of the receiving basin. So in this, according to this model, you have 7 different kind of deltas. This kind of littoral deltas from saline, marine, brackish, or also this littoral homopygnal littoral delta, like Gilbert Delta. This very interesting field of hyperpygnal littoral deltas or ramp deltas. This is very important deltas that had not been described before, because these are deltas generated by very low density hyperpygnal flow. These deltas form basically very extended ramps, where sometimes showing a lot of wave reworking. These deltas can be extended 4 kilometers, so I'm going to discuss later on. And of course we have this hyperpygnal subaqueous delta with channel systems and lobes, very important in Ordos Basin, as we are going to discuss later on. If you want some example of a present hyperpygnal littoral delta or ramp delta, we can see some analog to the probably the Ordos Basin, like in the Caspian Sea. In the north of the Caspian Sea, we have this Volga Delta. The Volga Delta is very shallow delta. You have here a ramp extended for more than 200 kilometers, and as you can see here, the gradient is very, very low. So you go from the coastline to 20 meters and the water in 200 kilometers. So the distribution of this delta is very, very low gradient. It's nothing to do with typical littoral deltas mostly described in our books. And this is a diagram showing the different kind of delta you have in nature. From the typical Gilbert Delta, homopygnal Gilbert Delta, you have these categories of hypopygnal deltas in which the density of the incoming flow is lower than the density of the water. You have typical marine deltas, marine littoral deltas. You have these saline deltas and these brackish deltas. Very important, are very poorly known. And on the other side, for the different kind of hyperpygnal deltas, we have these hyperpygnal littoral delta that form these ramp deltas, very important in epicontinental seas. For example, those close seas in which the density is sometimes lower because of the influx of water, say like some kind of brackish seas, and also very important in brackish lakes. And on the other side, when the discharge, the density discharge is higher, the density, you can go into a system of channels and lobes, typically of hyperpigmental subaqueous delta. Of course, you have at the end this category, the hyperpigmental fan deltas related to concentrated and hyperconcentrated flows. As we are going to see in the Ordos Basin, we are going to move into different kind of delta that are going to result in different stacking patterns along the different sequence we recognize in the Yanchang Formation. As a summary of the different kind of deltas, this is a paper that will appear next month in Journal of Paleogeography. You can see that a single sediment supply can form from littoral deltas, ramp deltas, or subaqueous deltas. All form part of different elements that respond to different relationship between the concentration and also the duration of the fluvial discharge. We can have different products entering the basin. So if you try to apply this delta sedimentation into the Ordos Basin, we had to understand how was the evolution of the Ordos Basin and what different situation we have for delta accumulation in Yanchang Formation. As you know, in lakes the situation is very different respect to the sea, because in closed lake, for example, these lakes that in which lake level is below the spill point, the accommodation space, the space available to accommodate the sediment, depends not only in subsidence, but also and fundamentally depends in the amount of water and sediment you introduce to the basin. Every time you introduce sediment, you introduce a lot of water to the basin. This water makes the lake level to rise, and consequently you are going to have a transgression. In this condition, it's not possible to accumulate littoral deltas, because littoral deltas need a stable level to prograde. So if your level is not stable, you have a transgression, it's not possible to create littoral delta. So the lake level will depend on the balance between groundwater supply, sediment and water supply by the system, evaporation, and of course the subsidence with control also the accommodation. So in lakes, we know we have three different situations. We have underfilled lake, in which the lake highly fluctuates according to sediment and water, especially water supply, but never reach the spill point. This transition, this balanced filled lakes, in which you have initially the lake is underfilled, but at the end the lake reach the spill point. So this is very important, because when the lake reach the spill point, all the excess of water and sediment supplied to the lake will be drained out through this spill point. So at this moment the lake level will remain constant. The last situation is overfilled lake. Overfilled lake is very common. All those lakes that has a permanent outlet. So when you introduce, no matter how much water you introduce to the lake, this water is not going to make the lake to rise. So the lake level will remain constant during the time, and all the excess of water will be drained out through the spill point. So these deltas, this kind of deltas, are very similar to the situation we have in marine basins. For example, it's nothing to do this kind of overfilled lake with the underfilled lake. So we are going to try to understand the relationship between this kind of situation, underfill, balance fill, and overfill lake, with the stacking pattern or the kind of sedimentation you have in the lake. For example, in underfill lake, we saw that all the sediment and water we introduce into the basin result into a transgression. So you are going to have a very well-defined transgressive system track with the coastal onlap as the lake level rise, and at the end we are going into a regressive system track. A regressive system track mainly because we decrease the amount of water and sediment, and consequently we have a lake regression. And in balance fill lake, we initially have a transgressive system track here, and at the end, when the lake reaches the spill point, the lake level remains constant, so you can have a progradation of littoral system during the IST. At the end, in Overfill Lake, the sedimentary sections are mostly thickening upward and quartzing upward, because the lake level is stable, is always at the spill point. So you introduce water and sediment and you will have a progradation of the system. So if you go into the stratigraphy of the Yanchang Formation, we can understand that the evolution, during the evolution of this basin, we go into these three kinds of different lakes. We start with an underfill lake with a very big variation in the lake level. Then we go into balance fill conditions in the middle mega sequence, and we go into the overfill condition for the upper mega sequence. All this lake condition will constrain the different kind of sediment or the different kind of deposit we have in the Yanchang Formation. We are going to analyze in some detail the lower mega sequence. A lower mega sequence is characterized by underfill lake condition. This underfill lake condition, or these lower mega sequences, as you can see here, phases analysis shows a dominance of lacustrine lobe complex and related channels. As a summary, in these lower mega sequences, we have a dominance of hyperpigmental subaqueous delta types. We don't have littoral deltas in this situation. Most stratigraphic and sedimentary succession this sequence are fining and thinning upward. You start with channels and proximal lobes, then you go to more distal lobes, and the end, after the maximum flooding, you have the regression. This regression, part of the regressive system track, or IST, is below this sequence boundary. In this part, typically with arid soils that mark this regression. For example, here you have a summary of the different water balance. When you introduce, of course, more water and sediment, you rise the lake level, but at the end, when the water supply is decreasing or stop, the evaporation made the lake level to fall. So we are going to have a forced regression, a climatically induced forced regression for this part of the sequence. So if you now, in this cartoon, we can see the whole evolution. From the beginning, you have this transgression here. Lake level is rising when we introduce water and sediment. and we migrate the coastal area from here to here, from 1 to 3. And after this point, you have the lake level fall because of the evaporation, and you have the subaerial exposure of marginal areas with paleosols. This is part of a forced regression, and also is a condensed section, as you can see in this Wheeler diagram here, with marginal soils in coastal area, and probably in the inner part of the basin you have organic rich shale, which are very important for the oil generation in the Yanchang Formation. So here we can see some examples of this deposit during this underfill periods in the lower mega sequence, dominated with channels and lobe system related to hyperpigmental subaqueous deltas. In this example, for example, this is the top, and you can recognize these red beds related to arid soils, marginal soils, accumulated during the IST, the regression of the system. And another example here, in a more wide scale, you have this the basal sequence boundary and these fining upward sequences in which we start with proximal channels and lobes, and we go into lobes more distal, and at the end you have the soils on top of the sequence, this red bed that marks the IST. You have the TST and the IST on top. And in the bottom, you have more or less this situation of hyperpigmental subaqueous delta, in which the flow bypass the coastal areas and transport the sediment to the inner part of the basin as system of channels and lobes. If we go into the middle mega sequence, it's very interesting because in this mega sequence, in each sequence you have an initial part in which the basin is underfilled, and in the last part of every sequence the basin becomes overfilled. So the lake level reach the spill point. So if we analyze the kind of phases you have in this middle mega sequence, you can see here we have hyperpigmental littoral deltas, you have littoral deltas, and we have hyperpigmental subaqueous deltas with channels and lobes. It typically form this kind of situation. At the beginning, you have this feeling of this the lake and the lake level, which is rising until reaching the spill point. Then the basin enter in the overfilled stage, so we can have a progradation of the coastal system with different kind of littoral deltas. So typically the sequence are fining upward and then quartzening upward. Fining upward at the beginning and then quartzing and thickening upward. So a very interesting event happened in the middle mega sequence, which is the breaching of the spill point. When the lake reached the spill point, the lake start to configure the spill point and configure the outlet for all the water from the lake. So as a consequence, this breaching result in a forced regression of more than 20 meters recognized basin ward. It's a very important sequence boundary here. It's above the main south rock here in the Chang 7. So in this diagram we can see an evolution in the middle megasequence from the initial flooding of the basin and the lake rising, the rising of the lake level with the coastal overlap and the migration of the coastline from here up to here. During this period we have the accumulation of this hyperpigmental subaqueous delta, and at the end, when the lake reaches the spill point, the lake level remains more stable, so you can have a progradation from the marginal areas with these littoral deltas. And at the end, when we decrease the amount of water and sediment supplied to the basin, we go into a climatically induced forced regression with subaerial exposure of marginal areas and also with some paleosols. You can see also a Wheeler diagram in the bottom, showing the relationship also with these soils and the probably accumulation of organic rich shales in inner areas. This is a more in a broad scale. You can see some small sequences in the middle megasequence. For example, here is very interesting, this B1.4 sequence. You start above the sequence boundary with this system of channels and lobes during the transgressive system track, and after some point we start with the progradation, very low angle ramp progradation. These are hyperpigmental littoral delta prograding this way. So as you can see here, phase is changing, forming this quartzening and thickening upward succession typically of the IST in the middle megasequence. Ramp deltas are littoral deltas, or these hyperpigmental littoral deltas are littoral deltas because they are attached to the coast but form very low gradient delta froms, low gradient delta system, ramp deltas. So very interesting in the middle megasequence, when the lake level reach the spill point for the first time, you can have the breaching of the spill point and the configuration of a new alluvial valley. At this point the lake level fall and we have a forced regression and marginal area with the incision. You can see the incision in Ordos Basin very clear with these incised channels, incising more than between 15 and 20 meters in the below sequences. So this is the typical situation of the balance field accumulation in the Yanchang Formation, with the channels and lobes and the upper parts delta, ramp delta deposits. Okay, the upper megasequence is also very interesting because it's the more similar to the marine sequences, because the lake level is almost stable and located at the spill point. So the typical sedimentary succession you have in this overfill situation is composed of this quartzening and thickening upward succession, dominated with these littoral delta deposits. The lake level, of course, can change, but just because of the subsidence. The water supply is always enough to maintain the lake level at the spill point. So it's very common to have this kind of littoral delta. We have recognized in the Yanchang Formation brackish littoral deltas and hyperpigmental littoral deltas. We are going to show some examples of how these deltas looks like in different situations. So in this diagram you can see the during the overfill condition you have water and sediment supply, so the sediment prograde in different delta system, literal delta system, as you can see here. This progradation of delta system make result in a regression. And after, when you stop sediment supply, the subsidence can make the lake to relatively go deeper, so we can have on top a transgression. And again, when you return with sediment and water supply, sediment can progress. So we are going to have different prograding system separated with these flooding surfaces. This is the way in which we build the different stacked small-scale depositional sequences in overfill lake condition. Here we can see some example of this small-scale delta system. Brackish deltas are very different respect to hyperpigmental littoral delta, because here, as you can see, the steep of the delta front is much more higher, and you go faster from delta front to lower delta front pro delta. This transition goes to very, very fast. And here you have a diagram showing an example of this situation. And also some examples about these small hyperpigmental brackish littoral deltas in the upper megasequence of the Yanchang Formation. This megasequence is very common to have very thick coal accumulation. These coal levels are very important also for the economy of China in this situation. And usually is related to accumulation in the delta plane related to the stacking of different small deltas, these brackish littoral deltas that are controlled by these autocyclic variations because of the location of the positional areas and the joint action of the subsidence. So, as a summary, we go back into the delta classification that is going to appear in this new paper. We can see that the deltas in the Ordos Basin in the Yanchang Formation mostly apply to this model, and you can recognize brackish littoral delta, ram delta or hyperpigmental littoral delta, and this hyperpigmental subaqueous delta. Most deltas in the Yanchang Formation are in this situation. So it's of course in underfill system is much more common to have hyperpigmental subaqueous delta. In balanced field system you have hyperpigmental subaqueous delta and ramp delta or hyperpigmental littoral delta. And of course in the upper mega sequences it's much more common to have this brackish littoral delta. Of course in this situation if you have a discharge of very concentrated flow or mixture of water and sediment, we can have also in the upper sequence the supply of sediments of sandstone to the inner part of the basin has hyperpigmental subaqueous delta. So some conclusion: the Triassic Yanchang Formation was accumulated in a complete suite of lacustrine and related continental environment from deep water to subaerial condition. But of course we know the existence of delta system in Yanchang Formation for a long time, but as we discussed earlier, these deltas can be a little more complex and can give an explanation for the different kind of element and stacking patterns we have in the Yanchang Formation. For example, in the lake body, we go in the Yanchang Formation, we go from underfill to balanced fill and overfill condition. Each of these conditions in the lake has different kind of delta. For example, in underfill lake condition, it's much more common to have hyperpigmental subaqueous deltas. But in balanced fill condition or overfill condition, it's much more common to have littoral deltas. We have just on hyperpigmental littoral deltas and also brackish littoral delta. But of course, the more common are the hyperpigmental subaqueous deltas and brackish littoral deltas in the Yanchang Formation. Okay, thank you very much. This is part of the team that work very hard in trying to get a new understanding from the Yanchang Formation. I'm very proud of our team, the Chinese, for the Chinese side and the Argentinian side. So thank you very much for attending to this speech.